so now we have a topic that is a neural network. As I got the input from the many students that neural network is a circuit of the neurons. That is a great answer I got it. We can say this is a collection of the neurons, and we can say the collection of interrelated neurons. Yeah, so that could be correct. So what is a neural network? What is the application of the neural network? We will see today in detail manner over here. And what are the various layers by which the neural network or neural network will be manipulated? So that is under computer supervised learning. Please keep in mind a neural network is an example of the supervised learning. After understanding this topic, or 2 days, 3 days, or 5 days after the 1 week, you will forget. So before forgetting or before skipping all these points, you people are required to keep in mind neural network is a kind of the supervised learning approach. So what is a neural network? We are starting from the our slide. Before moving to the neural network, here I am giving this definition. This definition is very interesting definition which deals with all the details. So here we have a differences between the AI and ML. Okay, here we have a differences between the deep learning as well. So as we have seen in the previous day while starting the machine learning course, so as we have seen this machine learning, so in the machine learning, artificial is the study of our human being intelligence. So how the human can intelligence. So this is what AI is what actually. This is the study of, I can write over here, this is the study of human intelligence, we can say human intelligence. But in the case of the machine learning, so machine learning is a subset of the AI in which we have to understand how machine will able to understand. In this case, we will understand how machine will learn. That is the concept we have seen. So this part we have seen through our supervised learning. In deep learning, so deep learning is a subset of the machine learning. This described that is the neural network. It is written over here. Deep learning uses the neural network. So I can highlight this point very smooth way. Deep learning uses neural network to simulate human-like decision making, and that is only supported by the one important point that is known as the neural network. So while discussing this point, what are the things we should have in the neural network, and that will keep the detail of our neuron. That will keep the detail of our neuron. So neuron are just like our information, or we can say the physical point that keeps in our mind or human brain. So in our human brain, we have the approx 1.2 billion neuron. So that is a point we have to understand. So the example we can understand, the people often tend to think that artificial intelligence, machine learning, and deep learning are the some application area where we can use the machine learning, or we can use the deep learning, we can use the AI. So all these things are interrelated to each other, but little bit difference we have to understand. Deep learning will be the part of the machine learning, and machine learning will be the part of the artificial intelligence. So that is a little bit difference we have to understand. These differences we have already discussed. So where the neural network will be understand, where the neural network will be applicable. So that is the point we have the deep learning. So differences we have already seen previously, but here we are trying to find where a neural network will be studied. So now after understanding this point, we have this term. Artificial intelligence is the science of getting the machines to mimic the behavior of the human. So we are trying to understand how machine can be intelligent, or how a machine can become intelligent. So that is a study of the that is a study of the our subject under coming to the artificial intelligence. And machine learning is a subset of the artificial intelligence that focus on the getting the machines to make decisions by feeding them data. That part we already discussed with the help of the various algorithms. Deep learning is a subset of the machine learning that uses the concept of the neural network. I can underline this point. Neural network to solve the complex problem. So to sum it up, AI, machine learning, and deep learning are interconnected fields. Machine learning and deep learning adds artificial intelligence by providing set of the algorithms and neural networks to solve data-driven problems. That is a highlighted point we have to understand. So these are the little bit difference we have to understand. I'm speaking once again. In the artificial intelligence, we have to study how we can implement our machine, or we can design our machine as an intelligence, or that is the study of the our human behavior, or maybe like the human behavior of a machine. And machine learning is a subset of the AI, as we have seen. So it will decide the how will machine learn to solve the any problem. And deep learning will we have to understand the deep learning will be learning will be deeply. And in this case, we will use the very layer to solve the many problems. So at the time, the very important aspect is required, and that aspect is known as the neural network. From this point, we have to start the neural network in detailed way. So this is just introductory part of saying to us why neural network is required. Tell me right now, this theoretical part is clear so far? Yes, tell me. The theoretical part is clear?
Yes, sir.
Okay, good. So better idea, or for explaining the better thing, I have done something over here. So I have done this picture. So let me explain all the thing. Now this is the our what this is known as the biological neuron. So this is our example. I can divide this example in two parts. One is a biological neuron, another one is a artificial neural network. So this is our biological neuron, and next one is the artificial neural network. Okay. So biological neuron. So in the biological neurons, we have the many terms, and each and every terms we have to keep in mind. This is the structure. See, this is the structure of the our neuron. So this we can say this is the structure of a neuron of human brain. Of human brain. We can write like this one. So in this we have the very term dendrite. So dendrite will use to take the input in from the artificial intelligence. So parallelly you have to see the differences. So in the biological neuron we have a dendrite, and in the artificial neural network that is known as the input. So in the AI, that is in the artificial neural network, what is the input we can take? So input we can take into the different form. And next we have the soma, S-O-M-A, soma, or that is known as cell body, and this is also known as cell. This is used to represent the node. And next we have the axon, or it is also sometimes known as the axon. So axon basically represents the output. So over the diagram of the biological neuron, you can see the axon terminal button we have, by which our output will be generated. Next we have a synapse. Synapse will be represented by the interconnections between the different axons. So this is the point you have to understand. Nucleus is what? Nucleus, or the cell nucleus, is basically known as the core part where it will keep the information and where information will be flown. So if I'm speaking over here in the biological neural network, then you can easily check x1, x2 are the two inputs by which we are taking the input. So in the AI, in the our artificial neural network, we have, this is our node. So if this is a node and this is our output, this is our output we can say, and these are the two inputs. We have the input x1 and x2 along with some weights. So these inputs in the our biological neuron is known as the dendrite, and node is known as the soma, or we can say cell nucleus, and output is known as our axon, and synapse is interconnection. So this is what, this is the some interconnection is required. So we can say this is the interconnection. Interconnections by some link. So we have this term. So now we have to understand the thing properly. So the little bit difference we have to understand how we are doing this thing. It means inspired from the human brain, we are designing the artificial neural network. So our structure of the neural network will be similar to the artificial brain or human neural network or a biological neural network. So what is the things we are using in the actual brain, that is a biological brain, and what are the terms we can use in the artificial neural network? So we have the same terms over here. So this is the term you have to understand. Artificial neural network we have transformed, so our node is expanded. Our node is expanded by the some mathematical approach. So we have this point right now. Those F is our function which is defined the our artificial neural network functions, and that is functions we can say it is used to define the our next process, and that is defined the in taking that is used to take the input and process the some data. So how we can processing, so that is to be depend on the our equations or our algorithmic steps. Now this is a little bit difference is clear to all right now. This is a little bit different is clear to all right now, the biological neuron and artificial neural network. Is it clear?
Sir, can you please summarize once again?
Which one should I explain?
Like in both part, in biological term and also in artificial network.
Okay, see, you can easily check over here. This is the diagram. In the biological neuron, we have a dendrite. This dendrite we will use to take the input. So whenever we are taking input in our human brain, so at that time, what is the entity by which we can tell that we have the dendrite? But in the our artificial neural network, how we can represent such terms into the form of the input? So we can say this is our input. So x1, x2 are the two input value by which we are taking. But dendrite is just similar to in our human brain, so which is used to take the input. So this is used to take the input. So I can write over here. Step by step, I am asking, is it clear to right now?
Yes, sir.
Okay. With the help of these two terms, soma or cell nucleuses, this is the just like the node which is able to take the many inputs. So you can see from the biological neurons, many dendrites are connected. So it means the person can take the input from the various sources, and all the information or the input will be processed inside the node, following by the some algorithmic step. So here I'm just depicting the same thing here with the help of my functions. So we have the FE. So FE is our function that is used to represent our node. So, but in our human brain, we have a cell nucleuses. Biological term we can say cell nucleuses or soma that is used to process our information based on whatever we have taken. Now, this is clear to right now? Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Okay, good. So now next we have the axon. So axon is used to represent it. That is this is our output we are generating. So now we are generating after getting the input, after processing the input. Now it is required to generate some information. That information is known as our output. So this output is generated by in the biological neuron in form of the axon. So the term we have in the biological neuron that is known as the axon. Okay, this axon is shielded by, or we can say it is covered by or coated by the myelin sheet. That is known as the myelin sheet. So that is the biological term. But in this myelin sheet is not applicable in our system because we have to take the only input, we have to process, we have to take the output. That is only in the computing term we have to use only these terms. Now it is clear to all right now.
Yes, sir.
So this is the differences between the biological neuron and our artificial neural network. So this is this artificial neural network. I can write over here for betterment. Used to compute some data, used to compute some input based on function. That is only meaning. So computation we can do into our computer system or our machine by using our artificial neural network. So artificial neural network is just similar to the biological neurons. So we have this point. Now let me know right now, this is clear to all, or you need to ask one more so I can explain. Is it clear to all right now?
Yes, sir.
Everything I am explaining, it is written over here. So is it clear to all right now?
Yes, sir. Clear, sir.
Okay, good.
Yes.
So this is another pictures of our biological neurons. So we have a dendrite. Dendrite means the receive the information or signal from the other neurons to get the connected to it. So means this dendrite will be connected to the other axon. I'm repeating once again. These dendrites will be connected to the other axon to take the input. So axon are giving the output and dendrite will take the input. It means our human brain, we have the 1.2 billion neurons. All neurons are connected to each other. So some is giving the input, some is giving the output, connected to each other. So our information will be processed in our mind. And what is the way by which our information will be processed? That is cell body, or that is known as the cell nucleus or soma. Now that is only meaning in the biological. Now it is clear to all right now.
Yes, sir.
Okay, so dendrite, we have to take the input, the cell body information processing happening here, and output to the neuron, nothing else special. So biological neuron and artificial neural network, we can say biological neurons or nerve cell. As you told me while asking this question, some student told me, sir, of course nervous cell, of course we can have. So this is the biological neurons, or we can say nerve cell. So this is, and this is similar to the artificial neural network. See, this is our biological neuron, and this is our artificial neural network. So my dear student, you can see when we have the nerve cell or biological neuron in our human brain, so that is similar to in the ENN silicon transistor, because our human brain is totally different from the ENN. So but how we can say what is similarity? So from this comparison chart we can see in our human brain we have 200 billion neurons. So now I'm updating my data. I was speaking 1.2 billion, but now we have a 200 billion neuron and 32 trillion interconnection. So interconnection means synapses. Here we can say the 1 billion byte RAM will be transformed, and trillion of the byte on the disk we can store. So this is the talking about the storing capacity. This was talking about the storing capacity. This is talking about the storing capacity. Now neuron size will be the 10.6 micro, or we can say very minimum size we can take. But in the case of the single transistor size, we have 10 to 9 micro. So this is the size we have to keep in mind. Energy consumption 6 to 10 joule per operation per second, because our mind or our human brain is required to process some data, so it requires some energy. So it is taking the energy approx 6 to 10 joule. But in the case of the human artificial neural network, we are consuming 10 to 16 joule per operation. Next, we have learning capability. So our human brain is just learning capability, but we can't program our human brain. So in our this artificial neural network, we have a programming capability by which our information will be programmed. So this is the basic terms we have to understand after understanding the biological neuron and artificial neural network. So this is a comparison chart we can see. Now, this is clear, or any doubt you have? So please you can ask me right now.
Sir, in AI, these have learning capability also, no, sir?
Yes, of course. So in the our see no, what happened in the artificial intelligence or artificial intelligence are talking me right now. So everything will be in form the program. So because your brain is not a program, you are following some instructions, some code that is stored into the chips, register integrated machines. We can integrate circuit. We can say. So by using the ICs chips, you are using you are passing some signal. So all those things are already programmed. So that's why we have the programming capability in the machine, in the AI and machine learning and deep learning. But in the case of the actual brain, human brain, real human brain, we have the capability that is known as the learning capability. Because whatever you are learning, that will be stored in your mind. I am learning from my past experiences. my this past experience or my learning will not be programmed. That will be stored into the machine from the past experiences, that is known as a data set. And from the data set, you try to interpret some information with help of some code. That's why we have the programming capability. So that is the differences. Now clear?
Yes, sir. Clear, sir.
Okay, good.
Yes, sir.
Yeah. Now, so simple definition of the neural network, what we have to study in our curriculum or course. So simple definition of neural network, I can say speak over here. So model in accordance to the human brain, a neural network was built to mimic the functionality of the human brain. The human brain is a neural network made of the multiple neurons. Similarly, an artificial neural network is made of the multiple perceptron. And multiple perceptron, what is will be discussed into the coming lectures. I have already highlighted this one, what is a perceptron, but I will give you just basic idea today. So before discussing the multiple perceptron, what is the perceptron of multiple perceptron? I will discuss later on. But here we need to understand what is the structure of the neural network in the machine learning or in the our artificial intelligence subject. So it is saying to us after giving the some input. So we have while giving the input, our information will pass on a layer, and that layer is known as the input layer. So from the input layer, you will pass some information. I can write over here. So this is known as our input layer. Input layer will keep the input data and will pass to the next level. That next level is known as the hidden layer. And this hidden layer will use to, here we have the two hidden layer. This is used to compute the data or compute the input. This is used to compute the input. Next we have the last layer, that is the output layer. This output layer will generate the output after processing this point. So as an initial level, we have a one input layer, one output layer, one hidden layer. So that's why we are talking about the single layer neural network. Okay, so step by step I will explain, but let me know right now. And let me explain it. We have the three different kind of the layer. One is input layer, which is used to keep the input, and hidden layer, which is used for the computation purpose, and output layer, which is used to generate the output. Now, this fundamental step is clear to right now.
Yes.
Yes,
Yes,
tell me
sir.
that. Yeah, okay. Any doubt over here? So please you can ask, because this is a very crucial topic we have to understand. So tell me right now, any doubts so far? Yes, tell me right now, any doubt?
So we can have multiple number of hidden layers also.
Yes, of course, we can also have. Why? Because our computation will be more computation. If you are doing the more computation, it means your output, your work will be refined. So input, we can have only the one input layer. We can also have the one output layer. That is the only point. But hidden layer can be multiple. Why? Because our computation can be more deeply. So that's why when we have the many hidden layers, it means we're talking about the deep learning. That is the point. So that is it. That is the reason the neural network will play important role in the deep learning. Is it clear to all right now? Yes, tell me.
Yes, sir.
Okay. So now I have the very slide which is totally blank. So I'm explaining all the concept over here. So that is a example I'm explaining. Let me take an example to explain the neural network in detailed manner. So this is the example I'm explaining. So first I am taking the input. This is the input. So we have the two inputs. Okay. This input is known as the x1 and x2. Say, am I right or not? This is the two input we can say.
Yes, sir.
Okay. So this is to be done at the input layer. I can write over here. So this is to be done at the input layer. Okay. Is it clear to all right now? As an input layer, we have to some input. We are talking about the two inputs, x1, x2. It could be many input, no issue. So tell me right now, this step is clear?
Yes, sir.
Now I'm just using the many node at the hidden layer for the computation purpose. I'm taking only 3 nodes. So here what I'm doing, this information x1 will pass information to this node of the hidden layer, and this will connect it to the this node, and this will be connected to the this node. And now same as x2 will connect to the this node, and this is connected to this node, and this is connected to the this node. So this is what I have connected with the my input layer to the another node based on the some weight. So input layer. So here I am just marking over here W1, W2, W3, W4, W5, and W6 are the weight. Okay, I can write over here y weight and input. We can connect to the other node at hidden layer. At hidden layer. Now clear right now? Is it clear to right now? Just tell me, is it clear?
Yes, sir.
And we have a one output layer, so I'm connecting this one like this one, and this is known as the output layer. So there is some other bits are required, so I'm assuming W7, W8, and W9. So you can observe over here the intermediate node that is known as the hidden layer, that is used to for the computation purpose. Input layer is used to take the input, hidden layer is used to for the computation purpose, output layer used to for the output generation. So I can write over here, this says the example of, this is the example of single layer neural network. Right now tell me, is it clear? This is example of the single layer neural network. Is it clear to all the students? Tell me right now.
Yes,
Sir,
sir.
in the hidden layers, there is no interconnection between all the 3 nodes.
No, why we're connecting? Because these all nodes are, see, this is a simple thing. Just look at this point. This node will take the input from the three different. It will take the input from the two inputs. One is x1, x2, and after computation, it will pass the message to the one output layer that is we have. Suppose we have the multiple output layers, so we can pass this output layer to the other output layer as well. So no connection will be between. So have you seen the interconnection between the two input layers? No. Have you seen the interconnection between two node output or more than two hidden nodes? No. That is the point. Now, for your more clarification, I just depict the diagram properly, so the thing will be clear. This is the point which describes the input layer. This is the point which describes the hidden layer, and that is the output layer. Now, yes, tell me right now. Is it clear to right now?
So in the hidden layers, all the 3 nodes are working together. Or
Yes, of course, because they will work in a layer. They will
okay.
work in a layer. So I'm talking about the layer. I'm not talking about the individual nodes. I'm talking about the layer. So at how many nodes we have in the input layer? So all the nodes in the such layer will work together, definitely. Yes. So this is a single layer neural network. Is it clear to all right now?
Yes, sir.
Any
Sir,
doubt? Yeah, yes, tell me. No doubt. Should I explain another example?
Yes, sir.
Okay, good. Now, let us move to the another example to explain my idea what I have. Now, let us take another example. So, first I am taking, see, I am making right now the complex structure. This is the input 1, input 2, input 3. So, at the input layer, I am taking the 3 inputs. So, I am giving its name x1, x2, and x3. As a hidden layer, we don't have the single hidden layer. When we have more than one hidden layer, I can write over here for a betterment. In English language, I can write when we have one hidden layer, more than one hidden layer, such neural network is known as multiple neural network. Multiple neural network. So why I'm creating the multiple neural network rather than the single neural network? Why? Because I need to do more complexity, and the application of multiple neural network we have used in the deep learning to refine the result. So this is our example. Now let me draw the example. So here I am taking the some input like I am taking the 4 nodes at the hidden layer. Just this for understanding purpose only and nothing else specially. So here now I'm connecting this one. So at the hidden layer I'm taking the 4 nodes. And suppose we have the 2 output nodes. It is also possible. We can also have the 2 output nodes that may have the 2 outputs. So from which output I have to choose in the classification. So neural network with the classification, we can also have the multiple output. It is also possible. Now, let me use a different color so the idea will be clear to all. See, x1 will connect this node. X1 will connect to this node by using the some weight. So I'm not trying to take the weight, but you have to understand weights are required. Now, it's clear to all right now?
Yes, sir.
Okay. Now I'm just using the different color. So this node will be connected to the this node, and this is same thing. X3 node will also connect to do so. Okay. So X3 will be connected to the this node, this one, and this one. So all 3 nodes are connected to the first hidden layer. So this is known as the first hidden layer. So I am writing in short way hidden layer 1, and this is my next hidden layer 2, and this is our input layer. So I can write in short way input layer. So we have only one, so no issue. So we have the input layer, and this is our output layer. So I can write the OL. So this is output layer. So far, any doubt? Tell me if you have.
No, sir.
Okay.
Sub can have multiple output layers now.
No. Output layer will be only one. I'm repeating once again. I can write over here for betterment. In a neural network, I can write in short way. In a neural network, there will be one input layer and one output layer. But they can have the many node. I was not talking about the layer. I was talking about the node. There could be many node, but layer would be only one. So one output layer. While hidden layer could be many. It could be one or it could be many. Okay, so that is the point you have to understand. This is the key term you have to understand. Now clear?
Yes, sir.
Okay. So in between you can say this node will be connected to this one. This node will be connected to this one, and this node will pass some information based on some weights to this one, and this will be this one. And again this will be passed to this one, this will be passed to this one. So every node will be connected over here. So I'm connecting here. So that is the point we have to understand. This one and last this one. Now, and the next level, what we have to do? The node will all the output of this node will pass on to the other part. So let me explain. This will connect it to this one. This will also connect to this one. This will be connected, and this will be also connected. But there is no guarantee every node will be connected. That is the point you have to understand. There is no guarantee every node will be connected. But the point you have to understand, I can write over here when all nodes in a layer are connected to all nodes of, we can say, next layer, connected to next layer, then that NN is called, that neural network is called fully connected neural network. Now, is it clear to all right now? This term is clear?
Yes, sir. Yes.
So, yeah, basic things we have to understand. So, I'm just depicting the things properly. So, the idea will be clear to all. See, this is our hidden, this is our input layer. And this is our two hidden layers we have. And this is our one layers at the output. So as per my words, there will be only one output layer, one input layer. So we have, and many hidden layers are also possible. So that is also possible. So we can also have the single layer fully connected. So it means all the nodes. This is an example. So this is an example of our single layer fully connected node. In this example, we can say multi-layer, or we can say multiple neural network, or this is also known as the multi-layer. I can write over here for a betterment, or for a this is known as the, once again I can write over here, this is known as the multiple neural network or multi-layer. Multi-layer, because we have the multiple hidden layer. Okay. Now, the basic introduction part, that how we can represent the neural network, is it clear to all right now? Oh, let me draw properly. So this was left. Yes. Tell me right now. Is it clear to all right now?
Yes, sir.
Excuse me, sir. Sir,
Yes,
is
tell
it
me.
necessary that every hidden layer will process the data and share the data to another hidden layer?
No, there is no necessary part if we are saying if they are not sharing, because there is no guarantee every node will be connected to the its next layer. So if it is not connected, then we can say there could be the example of the multiple or single layer neural network, but we cannot say that is the example of the fully connected. So when we have the all the nodes at each and every layer are connected to each other, then we can say it is fully connected in neural network, and that could be the single or multiple. So when we have the multi hidden layer, so we can say that is the example of the fully connected multi-layer neural network. Okay, and when we have the single layer where all the nodes are connected to each and every layer by the interconnection, so we can say that is example of the fully connected in single layer. But there is no guarantee. I already spoken and I'm speaking once again. There is no guarantee every node will be connected. But for example, purpose I have connected all the nodes over here. Yes, tell me right now. Is it
So,
clear?
so if all the layers are connected fully, then the data will shared fully.
See, why we are connecting the all the nodes to every layers node? Why? Because we are trying to increase the complexity of the neural network, so the computation will be more. So when we have the high computation and more computation, so our data or our outcomes will be refined. So when we have the data or the information in the refined modes, it means we are calling the deep learning. That is the reason we are calling the deep learning, because we cannot have the single layer or the single layer of the hidden layer. We can have the multiple layer of the hidden layer. So that's why we are increasing the complexity, and due to this complexity we are working on the thing, we are working in deeply manner. So that's why the term is coming from the neural network, that is the deep learning. So sometimes it is known as the deep neural network. What is the deep neural network? Deep neural network means we are working the neural network in deeply manner for increasing the more and more hidden layer. Hidden layer, what is the role of the hidden layer? To compute the data which is coming from the its previous layer, that is the input layer. So hidden layer first will take the input from the input layer. So after processing, it will pass data to the its next node, that is the hidden layer nodes. So it will pass data to the not only the single node, it will pass the data to all the nodes to hidden node, second hidden layer. So then a computation will be done. So the computation is done at not easy task. Computation will be done by the activation function. I will tell you, there is steps. So first I am discussing the structure only. Its activation function and perceptron I will tell you later on. But here I am taking the example of the how the neural network will look like and what are the various types of the neural network we can have. So and here the after applying the this input or the computation, our output will be generated. So a node will take the input and a node will generate the output. So there are two functionality which to be happen at each and every node. But at the input layer, no input will be there. But at the output layer, no output layer will be there. But in the hidden layer, we will discuss the two process. One is taking the input and process the input and then generate the output. So that is the beauty of the hidden layer. So all the computation will be done at the hidden layer. Sometimes for providing the confusion, we can say, or while reading the article over the internet, this hidden layer also known as the computation layer. So do not get confused. This computation layer is also known as the hidden layer. See, the computation, we don't know the computation, how it is computing inside the machine. We know the input only. I am giving the input and I am getting the output only. So that is a user perspective. But user doesn't know how this information will be computed inside the machine. It is computed by the multiple layer or single layer. So that is the point we have the term hidden layer. Now, clear right now?
Yes, sir, clear.
Okay, so anything you need to ask right now? Just tell me, anyone who need to ask a question. The structure is clear right now. The what is the neural network structure we can understand. Rather than the bookish thing, I'm explaining my idea only. So this is the concept we're discussing only. The concept should be clear. Single layer neural network and multi-layer neural network and fully connected neural network is clear right now. Tell me, is it clear?
Yes,
Just tell
sir.
me. Okay, good. So see, this is a one example I've explained to the other students. So I will not remove anything over here. So this is the same thing. Okay, so in dendrite will just represented by the biological. So we have the input, soma, cell nucleus, a cell body also known as the node, and output we also known as the axon, interconnection also known as synapse. So this example I'm also keeping as I explained with the other slots. Now this example I've explained to the other slot. So everything we have I've explained many times to many students. So I will not remove my previous data. I always keep my previous data. So I'm also having the same data. See this example. So there are many examples we have taken. This example, this example, this is example once again. Okay. So after understanding the very structure of the neural network, let me explain what is the important layers. So step by step we will see how, as we have seen, input layer, as the name suggests, this layer accepts all the inputs provided by the programmer. So here we have the 1, 2, 3 inputs as a diagram you can see, and now hidden layer. Between the input and output layer, there is a set of the layers that is also known as the hidden layers. And this layer is used to compute the data, and the result will generate to the output layer. So we will pass the result to the output layer. So output layer, this inputs go through the series of the transformation by the hidden layer. Finally, results in the output that is delivered by this layer, that is the output layer. Now, it is clear to all right now? The simple thing is clear. The simple program is clear right now. The simple theory part is clear to right now. Input layer, hidden layer, output layer. Is it clear to all right now?
Yes, sir.
Yes, sir.
Okay.
Clear.
Okay, good. So now that is a question. As I told you, we will see in the coming classes or coming slides. So that is the point. How does a neural network work? So at the time, the perceptron is required. So the perceptron is required. So to understand the neural network, we need to break it down and understand the most basic unit of the neural network, that is a perceptron. So a perceptron is, we can say, when we made a single layer neural network, so we will talk about the perceptron only. So when we have the multiple perceptrons, so multiple perceptron means our neural network will be formed by the multi-layer neural network. So that is the term we have to understand. But what is the perceptron? I will tell you. But the terms we have to understand. Perceptron we were discussing about means we are talking about the single layer neural network. When we have the multiple perceptron means we are talking about the multi-layer neural network. So let us understand the question: what is a perceptron? That is a big question. A perceptron is a single layer neural network. Now we have a term single layer neural network as we have seen. So the perceptron is what? That is single layer neural network that is used to classify the linear data, and we have the 4 important components of a perceptron. Number 1, input. So we can have the input x1, x2, and x, y, z. We can take the any inputs, no issue. And weight and bias. So far we have not discussed the bias, but here I am discussing the biasness. Bias is saying to us here, just let me explain the property. So the thing is clear. Input, we can take the input, just like example input, we can take the x1, comma, x2, x3, and so and so. We can take the main input. And weight. Weights are used to provide the connection between the current node to the next node. So what is the value of the such interconnection path? And that is value is known as the weight. And bias. Bias is also representing by the additional values in form of the weight, and that is used to minimize the error in the such neural network. So bias is the additional value that is used to minimize the error. Next is summation function. Summation function will be treated as just like this one. We have the input W1, so multiply with the its input x1 and multiply with its weight, that is we have this one, and plus W2 x2, we can say like this one. So this summation we can do starting from the I equal to 0 to n, suppose we are doing. So this is our summation function. And thereafter we have to apply the activation function to perform. So this activation means now we are activating we are activating neuron or neural, or we can say the node to compute the input, whatever it is received by from the its previous node. So activating neural, or we can say the node to the compute the input. So we have this point. So that is the point. Now this is example. So input we have the x1 and so and so xn. So irrespective we have its weight. So we are putting here. And summation function I am doing, so equal to 0 to n xi wi. Xi wi means input along with its weight we have to do, and this process is this element that is not the processing element, that is also identified by the summation function. And after applying the activation function, we will pass to the its next layer, that is the output layer. And if we have a multiple in hidden layer, then the previous hidden layer, the first hidden layer, will pass the output to the next hidden layer, and next hidden layer will process and then use the activation function to generate the output, and it will again pass to the next hidden layer if it is we have, else it will pass the data or output to the next layer, that is the output layer. So this is the point. So the input x received from the input layer are multiplied with their assigned weight w, and the multiplied values are then added to form the weighted sum. And the weighted sum of the inputs and their respective weights are then applied to a relevant activation function. And the activation function map the input to the respective output. That is only meaning we have to understand, but I have already explained this thing. So this is a diagram of the artificial neural network, and that is also known as a perceptron example diagram. Or this is this is known as the perceptron. Or we can say this is known as the structure of the perceptron. That is the point. Okay, right now tell me, is it clear to all right now?
Sir, can you once more please explain what is bias?
Okay, for explaining the bias, I can take the additional point over here, so the thing will be clear more. No issue. We are explaining this thing. See, my dear student, just let me explain this thing properly. So I'm taking the simple example where we have the two inputs. Okay, for explaining properly, I'm taking only x1, x2, and I'm connecting two hidden layer on two nodes at this hidden layer, and I'm taking the one output for understanding purpose only. This will be connected by the some weights. Okay, so this is the W1, this is the W2. This x1 is also connected to this node, so we have the another weight, that is a W3, and this will be connected by the another weight, that is a W4, and this will be connected by some weight, so I am giving its weight W5, and this will be connected by the another weight, that is a W6. And this is what this is our input layer, and this is our hidden layer, and this is the output layer. This diagram is clear? This diagram is clear right now? Tell me, this is clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So what is the wise actually? Wise will be the additional node or additional values that will keep the some values. Okay, so this is value I am giving, this is the bias B1, unlike the input value x1, x2. This bias is used to minimize the error. I can write over here. Bias is used to minimize the error. Okay, let me write correctly this minimize, else we will is used to minimize the errors in neural network. Okay, so if I need to connect this bias to this node, so it will be connected like this one, and it will be connected to this node. We can also connect. So let me inform you all once again. If I'm connecting the bias to the hidden layer 1, so all the nodes will be connected to such bias. We can't leave. So if we have the n node, so we have the n node in the hidden layer. If I'm connecting to the bias, all nodes will be connected. That is the point. Now, so it will represent some weight. So suppose this weight will be identified the W7 and W8. Now, clear right now? But it is optional. But in neural network, it is an optional parameter. Now, clear right now? Tell me,
Yes.
is it clear? Okay.
Yes.
So some students are saying to me, sir, can we add the bias at the output layer? Of course, it is also possible. We can also add the bias at the output layer. It is also possible. But try to avoid the output layer hidden layer. Just we can add the at the input layer. No need to use. But the hidden layer is also required to minimize at the hidden layer. We will use the bias to minimize the error or to minimize the error in the computation time. So that's why most of the time we will connect to the bias to our this network, that is our neural network. So this is just we can say this is an example of bias based neural network. Okay, now it is clear right now. Bias is clear.
Yes, sir.
Okay.
Excuse
So
me, sir. So why it is optional, sir? As it minimize
see,
error.
it is an optional. You can use, but it is an optional. Why it is optional? Because our input are required. For doing any computation, you just need the input and you just need the output and you need the processing unit. So for computation purpose, you require the three important units. Those are the input unit, processing unit, and output unit. So if you're adding the one more unit, that is the bias unit you are adding, so you are trying to increase the complexity of the network. We are trying to increase the computation time. So if you're trying to increase the computation time, so what happened? Our network will be slow. Our neural network will be slow. But while applying this thing to the neural network bias we are applying, so we can minimize the error, but our network or neural network will be slow. That is the point. So while working on the deep learning or deep neural network model, so our model will generate the output and it will take many times. It will take a few hours to solve our problem. Why? Because it is assuming there are some biases are connected, so computation is going into the fastly, but it will take many time. So it is an optional parameter is given into the neural network. But for solving any problem in this real world situation, you must have only three inputs, three unit. Those are the processing unit, input unit, and output unit. Why we are using the addition at this point? So that's why it is optional. But if you're adding for solving a problem at the computation time, so at least we can minimize the error. Because there is no guarantee what we are coding such neural network is perfect. So we need to do something what the calculation we have to do. Is it clear to right now? Is it clear?
Yes, sir, clear.
Okay, just I am remembering very important points over here, so I would like to share over here. What we are doing, we are reading input from left to right. I'm just giving the general information over here that is required. So this kind of a neural network is known as, so this kind of neural network is known as feed forward neural network. So all these terms, when you will see or when you will read into the books or various places, then you must be known to all these terms. So this is known as the feed forward neural network because we are reading the information from left to right only. Now it is clear. So in this our example, we have a single layer neural network. So we can say this is example of the feed forward single layer neural network. When we have the multiple hidden layers, so we can say this is a feed forward multiple neural network. Now clear right now?
So without bias, how much percentage of error we can get, sir?
Oh, that is the point you are asking me. Very good question you are asking me. We have to, if we are finding that is error, so error will be identified by the actual values and target values, actual values and predicted values. So we will see that some actual values will be given to the question, or our input will assuming this is our actual values, and we will apply the various activation function. We will apply we will use the input values, and we will use activation function. We will generate some output, and then we'll found that is some gap we are finding between the actual values and our predicted values. If we are finding some gaps, that gap is known as the error. That is the point. So that is error we can resolve by the neural network, that is known as the back propagation step. So before moving to the back propagation, let us understand this thing clearly right now. So that's why I'm just focusing on the feed forward neural network. I was not talking about right now and I'm not also talking about right now the back propagation step. Back propagation I will tell you, but let us understand the first basics of, and that is an example of the feed forward neural network. So is it clear to right now? This is clear.
So we can do some another work that without first we will do not first we will not use bias and see how much error we are getting. Then we can reduce it by using bias.
But I told you bias is used to minimize the error, but after applying the bias, there is no guarantee we don't have the error. There is no guarantee. Bias is the additional parameter that is used to minimize the error. That is not used to remove the error. That is the point. For remove the error, we have another kind of network, neural network, that is known as the backpropagation. So through the backpropagation, we will do this activity. That is a different thing. So before removing part of, before doing any other thing, but let us understand why it is wise and why it is required and what kind of network we are following. That is my point. Now clear?
Okay, sir. Yes.
Okay. So I'm not talking about the backpropagation. Right now I'm talking about the feed forward neural network. So so you can see what kind of a neural network we have seen. We have seen feed forward single layer neural network. Okay. Second, we have seen feed forward multi-layer neural network. And by default, whatever neural network we are following, that is under come to the feed forward only. And if we don't have the multiple hidden layer, so that's why we have the single layer by default. So this is also known as the single layer neural network or normal neural network. It means we are talking about the single layer neural network, and that is the example of the feed forward neural network. So when we have the multi-layer neural network, it means we are talking about the multiple hidden layer. And by default, we are following that is a feed forward neural network. But we must know to these terms because these terms you can easily see in the various books or various internet resources or various places. So you must be known what kind of the neural network we are following. So is it clear to right now? Yes, tell me. Is it clear so far?
Yes, sir. Clear.
Okay, got it. So after this point, this is the example of the perceptron. So now we have seen the what is the bias and everything. So perceptron is just nothing, which is just talking about the single layer neural network in which we have the input, we have the output, and we can have the many inputs. Of course, by one, by two, by and by. These are the number of the node in such a layer, that is output layer. And in the input layer, we can have the many inputs. So that is represented by the x1, x2, and so on, so xn. And we will apply the some processing part that is to be identified by the summation function or activation function, which is to be handled by our node, and that is to be example of the hidden layer. So what is the functionality of the hidden layer? Hidden layer functionality to compute the data based on our input along with the weight. Now this is the point. Is it clear to right now? So this is the perceptron. The perceptron is just define the functionality of our artificial neural network and nothing else special. Is this clear to right now?
Yes, sir.
Okay. So weight and voice, as according to most important term you will ask me. So why do you have assigned to weight of each node, each input? So once an input variable is fed to the network, a randomly chosen value is assigned to our input in form of the weight. So weight of each input data is point indicated how important the input is predicting the outcome. So what is the value of the weight we have? So it means what is the importance. So such input will execute or will take the computation first. So based on its weight, just like the priority. Just this example I can take over here. In a room, 5 people are entering simultaneously, but I will give the priority to those students, those who are known to me. So this is what they have the higher weight only. That is the only point. So weight is used to provide the priority to input for education purpose. That's why. So what is the weight? So along with the input, along with the weight of the input, we will execute simultaneously. And now, voice. Voice is a parameter, but it's optional. But that is used to adjust the activation function curve in such a way to precise the output precise output is achieved to minimize the error. So that's why it is written to precise output is achieved. It means our output will be close to the actual output. I can write over here for a betterment. Precise output means we're talking about the output will be close to actual output. That is point only. And y is a parameter used to minimize the error. But again, it's an optional. Okay. Now, is it clear to right now? The weight and bias term is clear to all right now? Yes, tell me, is it clear? The weight and bias term is clear to right now? Tell me any doubt over here.
Yes, okay.
Okay, good. So summation function is nothing which is just used to take the input and what is the weight we have. So along with its weight, we will multiply the input and weight and how many inputs we have. Suppose we have the n inputs. So I can write over here. This is the point. X1, W1 plus W2, X2 plus X3, W3 plus X4, W4. This can be written as summation of input 1 to 4 Xi Wi, and this function is known as the summation function. Now clear right now?
Yes, sir.
And activation function. The aim of the activation function to activate the neuron. Okay, I can write is used to activate the neuron, or we can say or node. So that is mapped to the weighted sum of the output. So what is weighted sum of the output? Say this is the output. What is the weighted sum of the output? This is the, and this is known as the weighted sum. So activation function will be mapped to the weighted sum of the output. And activation, such example, we have the 10H, ReLU, sigmoid, and so on. Now we have a sigmoid. If you remember my terms from the previous classes, sigmoid. Sigmoid, we have seen the logic regression. So here sigmoid is also applicable. So sigmoid is what here? Sigmoid itself is activation. Sigmoid itself is an activation function in the neural network. For example, we have the 10 and ReLU. So we will see each and everything in detailed manner, but here I am speaking about a simple point. So in the logic regression, we have seen the sigmoid function that is used to depict the input in two ways, that is 0 or 1. So the structure, the diagram we have, that is formed by the S shape. So we have the sigmoid, and that function is known as the sigmoid function, logistic function. So here we have a sigmoid function to activate your neuron. So we have this point. So these are our activation function example we have, and that is used to map the weighted sum to activate the neuron properly. So this is the activation functionality. Now, is it clear to all right now? Is it clear? Tell me right now. Any doubt?
Yes, sir.
Okay. So examples, we can take an example of the neural network. Consider a scenario where you build an artificial intelligence that classify the image two classes. So class A, that is containing the image of the non-diseased leaves. There are some leaves or set of the leaves. We have to identify if there are some disease in the leaves, so we can identify into the class A or class B. So when we have to find there's a leaves which are having the disease, so we can consider into the class B. So how to create a neural network that classify the leaves into the disease or non-disease crops? So unless it's theoretical part, just see this example. So what we are doing right now, I can explain over here. This is our image. Okay, so this is the our leaf image. Not leaf. I can write properly. This is the leaf image. Actually, I can write over it properly. Yeah. So this is the leaf image. So this image contains the many data. So each and every data in form of the pixel we have to take as an input. Okay. So here we are taking the input in form of the three inputs I am taking. Suppose that I am taking three inputs. So each inputs are connected to the hidden layer nodes followed by the bits which are not marked over here, but you have to understand we have seen. And our output are generated. So if you are getting the output, this is the form. So this is what non-diseased leaf, and this is what this is the diseased leaf. So we are founding from the what we have to go into deeply part. We have to go into deeply study. So this is the our image example by which we can see. But when truly speaking, while discussing all these things, we will take the numerical portion. We will not go to the image-based data. We will see simple calculation of the input, so we will understand the thing properly. But this is the example I'm taking here only for understanding purpose only. So in a leaf, we can have there is a disease is available or disease is not available. If disease is available, then we put into the such class as we will put into the different classes. So that we can classify the data based on the leaves are having the disease or not. So this is a simple example, and how, because we are doing the deeply study of a leaf in form of the image. So an image can have the many data in form of the pixels, because we don't have the limited amount of the pixel. We will have the thousands pixels we can have. So 1000 and row width and height, we have the multiple row pixels, and each every pixel will contain some important information which we can easily identify. So the computation will be more complex, and with respect to number of the rows or number of the height and width pixel, number of input will be 1000. So computation will be more complex for solving our problem. So this is our simple example I have taken over here for explain purpose only, just for understanding purpose only, and nothing else specially. So the process always begins with the processing or transforming the input in such a way that can easily process. So in our case, the leaf image can be broken down into pixels depending on the dimension of the image, that is the height and width, as I told you. So that is the point we have to understand. Suppose I am dividing my pixel 30 by 30. So total number of the pixel would be the 900. And now, just like our human brain, we have a neuron. So that helps in building the connecting thoughts. The artificial neural network has perceptron that accept inputs and process them by passing them on from the input layer on the hidden layer and finally the output layer here. So as the input passed from the input layer to the hidden layer, an initial random weight is assigned to each input, and the inputs are then multiplied with their corresponding weights, and their sum is sent as an input to the next hidden layer. That part we have already seen. So this is the point we have to understand what we have and what we not have. So from this point we have to understand what is the our information we are having properly or what is the information we are not having properly. Now this example is clear. I am not going to deeply part. I am not implementing anything, but I'm just giving some message over here. Is it clear to right now? This example, why it is replicable. So this is an application of neural network. With this example we are dealing. And here we have a theoretical portion over here. Okay, tell me right now. Is it clear? Sound simple doesn't. Sound simple doesn't it? Well, the concept behind neural network is purely based on the functioning the human brain. Because our human brain is too complex to think the many things. Simultaneously, we can think the many. We can store the many thoughts. We can think the many ways. So just like the human brain, we can implement. So you require in-depth knowledge for the various mathematics concept and algorithm for understanding the neural network. But it's my promise to all the people, no need to worry about the hard mathematics. We will take the small, simple mathematics by which we can learn the neural network. Okay, tell me right now. So far, whatever we have discussed in the neural network, is it clear to all?